What about you?
I'm doing pretty well. How about you?
Everything is okay. Actually, I was trying for the meeting at 2 p.m. I forgot that I was trying at 2 p.m. and I was unable to join.
Oh, you did? You forgot it was at
So,
4? Yeah.
yeah, it was at 4 p.m. So I was thinking that there is some technical glitch on my side.
Oh.
But then I rechecked the message. It was at 4 p.m.
Yeah. I have a slightly different time on Fridays, so.
Yeah.
So, what? I didn't know they had the time up here now. Oh. So what? Notice that you've been attending meetings for the last couple of weeks. So, what is your impression so far?
I think everything is going great, but we should, increase the pace. We are being quite slow. Everything is going decent, but I think we should increase the pace of our work.
Okay.
Rest everything is pretty good.
Yeah. So, what were you wanting to do in the group? I mean, did you have an idea of what you wanted to do yet, or?
Yeah, actually, I was searching for a few data sets that we can do for, that movement prediction. So I think I can help with that.
Okay.
That project, Mike's project.
Yeah, well, that's actually something he's doing for the community period. So his main project is, of course, different from that a bit. But yeah, I think that would be a good idea, though, to have that, to drive that forward a bit.
Yeah. So I wanted to ask something.
Yeah.
When we have to make feature extraction models of biological data, right?
Well,
Hello?
we
So we have to make kind of encoder decoder models.
Yeah. So I guess I don't know if have you seen the movement data?
Yeah, I've seen the movement data.
Okay, so that's the raw data, and then the idea would be to make take some sort of machine learning model, and yeah, and so I don't know if we have any that would be basically the feature extraction part of that, but I don't know how much labeling there is of the data.
No, can we make a general biological model, like taking a data of X-rays, then taking data of MRI, then taking plant data, taking everything biological that we have? I'm not talking about the feature extraction part. I'm talking about the feature extraction part. I'm not talking about the movement part. That will be another model. As I'm talking about the biological part, a feature extraction of biological data. So what we can do, we can take every labeled data that we can have, then more the data, so merrier it is. So taking everything that we can get and then compiling it and then making a biological data, and then a biological model, then making a movement prediction model else. Like there was thing as U373, and there is something NIH3T3. These are having more what you can say. These were movement. There were data sets having the movements of the cell.
Yeah.
So I was thinking that if we can make a feature extraction model, which apart from that our movement prediction model, a feature extraction model which takes everything biological that we have, MRI, X-rays, if we have labeled plant data, whatever we get.
Yeah.
Because it is because the annotation of you can say the medical image annotation is readily available in Kaggle or this RSNA, that radiologic North Indian, that's something that Radiologic Association of North America, that they have plenty of data with annotation. So what we can do, we can take the segmentation data and make a whole segmentation model.
Yeah. You mean like
And
for
then,
everything, for all sorts of different types of data?
yeah, and you can say all in the data, so that then we can version it with ML flow. Like we have Git version of every software and all. We will make a versioning of that data using ML flow. Then we can again, after some time, when we get more data is released to the public, because we there is limitation in medical imaging because of privacy and ethical issues.
Right.
So all we have to work with only that data that is, you can say, ethical for us to use, like that one provided by RSNA, or which is publicly available in Kaggle.
Right.
So we can make an general biological feature extraction data. I can help with Mayuk to design a custom CNN, custom layered CNN.
Okay.
But we will need a GPU for that, a good power GPU, and is that available?
We don't have any resources like that on our side.
Okay.
So
Okay, I'm having a GPU. It's 4GB 1050 NVIDIA, but it would be, I think it would be not sufficient to handle that. But we can make prototypes on that.
yeah.
Then we can get cloud services like AWS, Paperspace, or Google Cloud GPU.
Yeah.
So me and I can design a custom CNN. Like we use ResNet 50 with 15 layers, or ResNet VGG 16 with 16 layers. I will make a custom CNN, 2-3 prototypes, and see which one works better.
Yeah.
That would be, and we can name it like OpenWorm CNN, something like that.
Yeah.
Like we have ResNet and VGG, InceptionNet and EfficientNet. So we can name it OpenWorm, yeah, or Worm CNN.
Yeah. Oh, I mean, it sounds good. I mean, like, so, well, I mean, the only thing I can think of is that there are a lot of, like, if you go from, like, I guess the general aspect of it is interesting, though. Because, I mean, the caveat I was going to give was that you have so many different types of data. Are you going to be able to extract useful features? But on the other hand, I think that's actually kind of what we want. A lot of groups will take like specific types of data and train a model, and then get a high result. But it's like you're trying to find specific features specific to that data set, so they don't necessarily generalize well.
Yeah, because we sometimes have, you can say that digital pathological data, it's a very high resolution image. So some people have, X-ray data, so we can combine everything biological thing.
Yeah. I think that would be good. Well, we'll see what happens. I mean, if we try like cross training it on like data from like cell biology and data from like radiology, we can get like maybe some meta features or something like that where it's like not necessarily specific to either data set, but you find it. But I don't know. Well, we'll see what happens. Maybe that's useful to, and maybe it's not as useful.
Maybe it's not.
Yeah.
And I want to, put plant data also, because I think plants are mostly ignored in science.
Yeah. With plants, it's like you can get, I think, just high resolution images even, but I don't know. I think there is
digital pathological images.
Yeah, they do have embryo data. I think for Arabidopsis, I think is actually which is like tobacco. In the seed, you can see the embryo actually pretty well, and so they actually do a lot of studies on Arabidopsis embryos. But I don't know if that's how publicly available that is. But you also have more common.
But I think it would be available. Plants don't have privacy issues.
Yeah, not yet.
Yeah, we can look at that. So, how's that COVID thing going in USA? It's
not great. Yeah, I mean it's people are trying to open up again, but it's like you're getting spikes in cases, so it's going to be like that for a while, I think. Yeah.
I was coming to USA St. Louis this July, but the conference got cancelled due to COVID.
Yeah, we had a lot of virtual conferences now. I don't know, like they're moving it virtually, but like they just did a virtual conference this week. So they've organized it sort of. In a couple weeks they organized this conference, and it wasn't even like it didn't even exist before, but they were able to get people who had missed out on canceled conferences, and they came into this conference, and so it's a shame that everything's getting canceled, but we have to be safe, and we can use this kind of technology to make up for it a bit.
I think from next year onward we will be having VR conferences.
Yeah. Well, I think the time's come for virtual conferences. Like, people have been talking about it for a while, but they've been hard to sort of organize at scale. So I think finally we're getting some good technologies implemented that make it possible. So.
Yeah. Necessity is the mother of invention.
Yeah.
Like the boom that science had after during World War II, it's the same here.
Yeah.
A lot of new things were invented during the World War. We were fighting something. Now we are fighting an invisible enemy kind of thing. So many new things will be get invented. So, how's work at orthogonal research going?
Oh, pretty good. Just trying to, we're doing a lot of virtual things, and we're trying to, we usually work towards papers or some sort of output, but we also do a lot of stuff that doesn't get, like, we just try to move the ball on different things as much as we can. It's not there's Vinay. It's because we don't have like a formal source of funding or like an institution higher up at an institution. We don't really, usually stick to a really tightly organized plan. But we usually get, we just take the opportunities where we can find them. So.
Yeah, I try to contribute there also.
Yeah.
I was going through after publication. Mostly stuff got above from my head. This was more like to biological stuff, but I really found that interesting.
Yeah, definitely.
So.
Yeah. Hello, Vinay.
Hello.
Oh, here you are.
Hi.
So what's new with you?
Nothing much actually. The regular stuff. We're working on my undergraduate thesis actually.
Oh, good. Yeah, that's good. What is it on?
It's basically on text to image conversion.
Okay.
So like if I given an text saying that a bird is sitting on a branch, so the model should be able to generate an image which would depict something like that, like a bird sitting on a branch, and I can also add details like with red feathers and white tummy like that. So we are working on an iterative version of that actually.
Oh, wow. So the text part is, what's the text part, like the descriptions, and then your
Yeah,
images?
the first, the text is like sent into a recurrent neural network. So when we extract the features from that text, and then we while training, right, we will have both the text and the image. So we would extract extra features from the image as well, and we use GANs to basically we will inject these both into this generator and ask it to generate a image actually, and then the discriminator job is to like identify if it's a fake or a real thing. So parallelly, on an iterative process, both the generator and discriminator will be learning. So finally, we would be using the generator.
So what do you envision it as being used for, like for application wise?
Yeah, actually, the thought was to like this would enable to fasten the media content creation, right? So, like when we want to articulate something, it would be better. Like someone would understand it better when we show an image, right? So, so basically. We can grasp more information and retain that information easily when it's presented in an image form. So we're trying to bring this to like maybe into education sector where instructors or creators can use this to form to make graphics easily.
Oh yeah, sounds like a good application.
Thanks.
Yeah. Look forward to maybe you can show a demo or something sometime when you're up at that point where you can show things.
Yeah, it should be done by next month or maybe July, early July.
Oh, good. Yeah, that sounds good.
Yeah.
So Krishna was talking about he had oh, go ahead.
No, nothing. I was just gonna ask about like if Ujjwal would join or something. Are you please continue?
Oh, yeah. So Krishna had an idea for like a general purpose machine learning model for biological data, and he was talking about it a bit. So, Krishna, why don't you tell Vinay, like maybe in about 2 minutes or less, the idea?
Hi Vinay, how are you?
Hi Krishna, how are you? Nice to meet you.
Yeah, same here. So I was, hello. Hello.
Yeah.
Sorry, I think my microphone got turned off. So what I was saying that I wanted to make, no, I don't want to make, I want that our community to make specialized models for biology. Like we have that ResNet, InceptionNet, all of those are trained on ImageNet data set that usually contain car, dogs, etc. So I want us to make a model that takes input of biological data like X-rays, MRI, plant-based data, microscopic data, digital pathological data, everything, anything that we get, anything that we ethically get and that we are, we have the permission to use that. So we train, we trained that all big chunks of data and we trained it into a customized CNN and then making, you can say a pre-trained model that may be named anything like OpenWorm CNN or anything CNN, just like the ResNet model or any InceptionNet or VGG model. Those are so we customize the layers of the CNN. Like we make some prototypes taking 6 layers, 7 layers, 10 layers, whatever suits us at that time, and then we compare the performance of all the CNN, and then we take two CNNs, like one with large layer, like if you take the example of ResNet, we have two models, not we have two models, we have many models like ResNet 18, we have 50, we have 101. So what we do, we will make two models, one with small number of layers, which will be computationally fast, but its performance will not be it will not be having state of the art performance. Then we will make another model which will be having state of the art performance, but its layers would be long, so it will take more time to train, and it will also take a little more data. So what we can do, we can make two models, like light model and the standard model. So what we are basically doing, we are taking any biological data that we get, training it for feature extraction, and then making a pre-trained model that can be, that can be used specifically for biological purposes, irrespective whether we are using it for, radiological data or anything, any biological thing. We are taking every data possible that we can get, and then training it for feature extraction, then it can be used. And I think if we are giving it more domains of data, like we are giving it plant microbiology data, we are getting it radio, MRI, anything, so more will be the diversity. I think better would be the performance, and it will be better for an in general use. So instead of that ImageNet, instead of that, training it for that cars, boy, cat, and everything, we are training it on biological data. That's it.
Yeah, Krishna, that sounds good actually. But like in that model, is it specific to classification or segmentation? Did you think of that as well?
No, first we will make only feature extraction. Then if a feature extraction model is made, it can be used for segmentation also. Like when we use units for segmentation, they are mostly used for biomedical segmentation. They itself mostly use ResNet for feature extraction. So what we are doing, we are going to make a feature extractor that can be used for, you can say, for classification, also for segmentation also.
Oh yeah. That's
So we can
that's really nice.
everything else with respect to our feature extraction. Like mostly ResNet is used, so which is trained on ImageNet. So instead, feature extraction model only specific to biological data, trained on biological data.
Yeah. Yeah, this would like this really sounds interesting, and we could actually do this. But like maybe we might require a heavy GPU, because when we aim to compare this with a model like ResNet or AlexNet Inception model, like that has been trained on heavy GPUs for hours and hours with millions of data. So to reach that accuracy, we might well need as much data as possible. But I like the idea actually to make something specific to biomedicals, like which can be taken off the shelf directly, like without depending on common objects, like models which have been trained on common objects. So there's a similar project actually which Mayuk is working on during the summer. So probably post GSOC, we can try to discuss this with him as well. We can involve him as well, because he's primarily working on pre-trained models, and maybe then we can see where how can we take this forward, and what it can be.
I was also worried about the GPU, but I was thinking that we can make prototypes, then we can make the whole model later after we get the GPU.
Yeah.
We can contact AWS, Azure, or Google. They usually give free Google credits for research, and since it's an open source research, they might be get interested in give us free GPU instances.
Yeah, that sounds good.
Yeah.
Cool idea.
Yeah.
So we can do it after GSOC or within GSOC, whatever time permits. And I was also thinking not only making it in Python, but also in Swift. If you remember my proposal, Bradley.
Yeah.
Yeah, I wanted to do it.
Yeah, you did propose Swift.
Yeah.
So Swift, so tell us a bit about Swift. What's the advantage of Swift versus like Python?
Okay. Like now Swift was developed by Apple for their making apps on of their platform, but actually the lexical parsing of Swift, if you go into the compiler level design of Swift, it's quite an efficient language, and many people predict that it will overthrow Python in machine learning because of its fastness, and also because of one thing about Swift is the way it is made, the way it get compiles. It is better than Python. Python is not a fast language. It's it's many times, even 1,000 times slower than you can say C or C++. But that will not be the case with Swift. And many people like that. Jeremy Howard of Fast.ai. He is also teaching Swift nowadays. In his last lecture, he was emphasizing on Swift. So I think that Swift has a lot of future potential now. And one thing else, that not a lot of people are working on Swift nowadays. So if we will work on Swift, that it will be a head start in the language. We would be the first one to implement something that in Swift, and it's not a very tough language to learn.
Yeah, it's probably
It's not like Java.
Python adjacent, or like if I knew Python, I could learn Swift.
Yeah.
Yeah, in my other group that I work with, last summer we did a GSOC project, and the person doing the project chose Kotlin, which is another sort of Python adjacent language, and it's a lot better. And then more recently, we've been getting into Julia, which is a scientific computing language. So I think that's good to have maybe a variety of different languages to explore and see which ones are best for different tasks. That's good.
Because the problem with Python is that it's not fast, but it has an advantage of community. Python is backed by great, it's having great libraries, but I think when time comes, if Swift will get that support, it will overthrow Python as the king of languages. Yeah.
Well, I think it's more like if your community does like what you do. So, like if your community is small, but you have people who are doing kind of what you're doing, and you can, there's a brain trust there, kind of know how to solve that problem. Python, it's like you have a lot of people doing it, and you might get like good, you might have a big community, but and most things can be done in Python, but it's kind of like sorting through a lot of the trying to find the right person is a little bit harder. But I like the idea of having like more specialized languages for things.
Like you're having output statistics.
Yeah.
So domain specific languages are better.
Yeah. Well, yeah. I mean, for the task, but if you want to, in an open project, if you want people to contribute, it does limit you somewhat because you have to find a person who knows the language, and then, but that's not, it's not usually that much of a problem. I think this is a nice project to pursue. I think there are a couple of things we have to do first, and then, like Vinay said, we might do it after GSOC. But I think
we can take it for GSOC for next year. It can be it's an I think big project. It can be a GSOC project for next year.
Yeah. Well, yeah, and so one of the things we can do
if it's not done by that time.
Yeah. Well, one of the things we can do is start off like in steps. So this is pretty ambitious, obviously. Yeah. So the first thing we want to do is find data, like get a good data set. Like if you say that we want all sorts of data, we need to find some good data sets that can be analyzed. And that includes like having, labeled data.
Annotation is
and then a wide variety of data. If we're going to do a general model, It needs to be pretty diverse. Yeah. We need to balance our classes, so we can't just have like one plant data set and then a bunch of microscopy data sets and a huge amount of radiological data. It needs to be sort of balanced.
That would be create a lot of bias.
Yeah. But I mean, not even in the sense that we need to be able to create like classes that are,
Balanced classes.
Right. So that's probably the first thing we need to do. Then maybe the next thing we need to do is figure out if it can be done at a small scale. So before we try to do any GPU stuff, we need to
we can make prototypes.
Yeah, make small prototypes. And you said you have access to a smaller GPU, which would probably be good for that stage because you could just take and then I think then maybe we can scale it up. But then of course if we want to do it for GSOC next year, we can propose a project that is maybe in that direction.
We can make a head start. We can complete, you can say 30-40% of the project. Then after that, the rest can be introduced in the next GSOC. We can start it off and see where things goes.
Yeah, and then there might be other opportunities to fund it, both on the side of like people, but also in terms of getting good computational resources. So there are people, and after I did last fall we did a bunch of, I don't know if you've seen the DevoWorm ML stuff, Krishna, but and Vinay was in the DevoWorm ML group last fall, but we had this, this is when we started thinking about the pre-trained models thing for biology. And so in the time we wrote a blog post, and then we did the GSOC project. In that time, there actually have been a couple groups that have been putting out pre-trained models, but they're like one group is doing it for different features of biology. So there's a group, I think out of Alicea Farm, which is a research group in Krishna left for a minute.
I think his network is lost or something.
Yeah, I'll wait for him to come back. Okay. Are you back?
Technically.
Okay, yeah. So, all right. So the group that I was referring to, they did this. They've been creating these pre-trained models, but they've been on specific parts of like a cell. So I think they're taking eukaryotic cells and they're building pre-trained models to segment different parts of the cell. So like I think one of them is like mitochondria, and another one is like because like the cells are pretty complex, and if you want to find things in the cell, I remember we did this project when I was at it wasn't that long ago. It was like maybe about 7 or 8 years ago. There was someone doing a project where they were trying to take like microscopy images and find mitochondria in the cells, and it's like they did this by hand. I mean, they did it like a person. Like people would have to identify them and count them, and you had like they were fluorescent markers, but it was like that is not that is very painstaking and hard. But I think they're building a pre-trained model for stuff like that. So just little features within the cell. I think there's another. I have these linked in one of the repositories. I can't remember what it is right now, but there are a couple people doing pre-trained models. But like I think it's like baby steps. They're like getting little features out of cells But I think there's, of course, again, there is this value of like a very general model. So like if you want to like figure out, and I'm trying to think of what might be in common between like all these different types of data, and I think about like the Alicea paper that we wrote. I don't know if you've seen that paper. Did I send it to you?
No, I have not seen it.
Okay, let me send you a link to this. So this is a paper that we did from last summer's work, GSOC related work, and this was on a microorganism called Alicea, and this is the paper here. So I'll put it in the chat. And it's, all right. So this paper we had, Ojwal actually was involved in the segmentation of the Basel area using a pre-trained model. So we used DeepNet version, or DeepLab version 3, which is, pre-trained model, a very general one though. It's not biologically oriented. And so the problem with that model is that you have very nice techniques. Oh, okay. Yeah, let me see it. Can you send Jesse the link to the meeting, Vinay? Or I'm not on Slack right now. But the thing is, their model, they trained it on a bunch of models of images like cars and things like that. And so it isn't specific to biology. So what they basically have are these rectangles, bounding boxes, and then you have to fit your feature within that. So that's a problem with a lot of non-biological pre-trained models, is that they're very square. And biology is very circular or curved, if that makes sense. Because it's like, you have things like cells and organelles in cells, and they're very elaborate, but there are a lot of curves, a lot of bending and folding and things like that. And so that's one of the things about like a biological model or a pre-trained biological model, is you want to get those kind of features where it's like you have bends and curves and flows. So it's very different from bicycles and even faces in some ways, because it's faces, you have some curves, but it's like you're picking landmarks on the face. They're a number of different landmarks they know that are variable across the face. You're not even really picking curves on the face, you're just picking landmarks a lot of time. So that's one of the challenges of this stuff. Is it has a very we're trying to find very different things about the data.
So good data with bad algorithm performs better than bad data with good algorithm.
Yeah.
So it's always about data.
Well, the other thing too is a lot of data. It's hard. It may be very nice, visible, but there is an aspect of pre-processing. So we have last summer, and Vinay will tell you this, we had issues with pre-processing the image. So you have things, even if you have a very nice high-resolution image, like a microscopy image, you have background, and boundaries are very hard sometimes to get defined precisely. We found this out just recently with the movement data, that you can segment a worm, but you still have parts where the edge isn't complete, so you get these gaps. And that might, so we want to keep that in mind with data that we select for this.
That goes with everything.
Yeah. But with biological data especially, it's you get.
But sometimes, for example, max lightening. Sometimes if we change the lightening, the things get different. For example, if we are predicting cancer and the dark region is cancer, and if we are making everything dark, then it will make everything different. Yeah. So that pre-processing has to be taken in mind.
Yeah, and the other thing too is a lot of these data are acquired in volumes. So the volumes are, slices of the body or the cell or whatever. And so there are different planes where you have data, and it's not your boundary doesn't conform to that plane. Sometimes it goes up like this and over. And so the image will show the boundary clear in some cases, but very weak in other cases, or non-existent. And so, there are maybe opportunities to put some of those slices together, but that's another whole separate processing issue. So it's hard to really approximate some of this stuff.
Then there are many approaches. There is one thing that two-stage CNN. that analyze the whole image. Then it divides into different parts, patches, and then it analyzes the patches. So we can, we can check all these things. That instead of making a single CNN, we can use the concept of two-stage CNNs, like analyzing data in two stages. First, as the image as a whole, then the patches of the image. So we can, try and test a lot of things, make prototypes of different things, then see which one works.
Right. Yeah, I think it's, but I think it's a good idea. I think there's a lot we can learn from that.
Yeah.
And I don't think people are thinking about it too much outside of, yeah, Jesse just pinged us here. I don't know if he's going to come in, but I'll send him a little message here. Anyways, yeah, I think it's a good idea. I think, yeah, people aren't really thinking about it in that way. Like I said, people are thinking about it in terms of like, specific things that they want to know, specific features they want to extract out of the data. But then, of course, there's this whole issue about biological sort of theory and how people don't think that, like, there are a lot of universal things that you can find because there's just too much variation. But
first training it on bicycle, then training it on bones is better than training it on biology and then training it on bones. Yeah.
Yeah. Well, I mean, like if
it's better where we start from, like bikes and mitochondria have nothing in common.
Yeah. Well, it's just that, like, if you could imagine, like, if there's a theory of things, like bikes and faces, and I mean, they're like psychologists have kind of, there's a psychological theory about how faces are processed and how objects are processed, and so there's actually this basis for knowing that there's some commonality there in terms of human perception and then machine perception. But like with biology, and it's like, I don't know if maybe there actually is some literature on like biological motion perception, where they put a bunch of dots up on a screen, and it's like a human moving, but it's like someone wearing a suit with a bunch of markers on it, in the dark. So it's like a bunch of lights moving in the formation of a human stride, and people can recognize that as a human being. Hi Jesse, how are you? So there is that aspect of like you can perceive biological motion or something like that, which is like a higher order feature of biology, right? Like we can recognize biological movement from mechanical movement, maybe, but the false positives can be very high on that because, as you can imagine, you have, you see something that looks like it's living, and it could just be like something flapping in the wind. And, we see that in like these images. You'll see things that look like they're, something really exciting, and it's just kind of like a physical process unfolding in the image in the background, like some gas bubble, like expanding and contracting. Yeah.
So we first have to code and train and then check that how thing goes. So I think during next meeting we will create a rough draft, and then after we'll start working on that.
Okay.
At least we'll make the first prototype.
Yeah. Why don't you plan on giving a short presentation on it at some point? Like just put together like, before you do a prototype, because I want to get some feedback from people before you start off.
Yes, I will.
Okay.
Coming Monday or next Friday?
It could be either one. Maybe the Monday meetings, there are more people in it. So you might try Mondays. Maybe not this coming Monday, but the following Monday. So Yeah. All right. So so Jesse, Krishna was talking about building a general model, a machine learning model of biological data. So like looking at all different types of biological data from microscopy data of like embryos and cell biology to radiology images to even like plants, images of plants, I guess. So we were talking about the pros and cons of something like this, and I think it'll be interesting to see if it's I think we'll find something interesting, but I think we'll have to focus on like how to create sort of like classes of data that are like if something's moving versus if it's like a type of image where you're just trying to diagnose features and things like that. I think that's another important thing because you're not gonna if you put something in where you have like some flow versus like you're trying to find like a tumor, that's not really comparable. You're going to get a lot of mess out of that. So I think also finding like common processes, maybe even if we have to test a bunch of different, at a small scale, test a bunch of different things to see if they're like common. But okay, Vinay, thanks for attending. Talk to you Monday.
Bye, Vinay.
Yeah, bye, Vinay. Have a good weekend. Jesse?
Yeah. Thank you.
Yeah.
Thank you.
Yep, thank you. So, Jesse, what's going on with you recuperating from the Neuromatch conference?
Hey, that's exactly right. I am recuperating from the Neuromatch conference, and I'm recuperating from they weren't all major events, but I've done more things since April 1st in like a 2-month period than any other period that I've done.
Wow.
Yeah. So also I'm actually literally recuperating because I still have a mildly, it's not anything big, but I'm actually literally right now preparing some ginger. I'm going to make like real ginger tea because I have a bit of an upset stomach. So I'm actually recuperating. I'm totally fine, but like I am recuperating.
Yeah.
How are you guys doing?
I'm doing okay. Yeah. How about you, Krishna? I think he's doing fine. Yeah.
I kind of missed.
Yeah.
Oh, I wasn't quite sure what. I don't think I've been to a hack hour like this before, so if you want to fill me in on like what it's about and what has happened in the past, so I know a little more about it, that's fine.
Yeah. So this is an opportunity this is sort of more of an informal meeting than the Monday DevoWorm meetings. And this is kind of a place for people to come and pitch ideas or to show demos or ask questions. If it's like, if it could be GSOC related, it could be some other project related. Because as you notice, we have limited time in the Monday meetings. It's kind of like, there's so many things going on. It's kind of hard to balance it all without a second meeting, I think. But I think this is good. I hope that more people, attend over time. But I think this is, Krishna was talking about a project he wanted to do, which is sort of an extension of his GSOC proposal, but kind of related to the work that we're doing with pre-trained models and yeah. So, and then that's something that we can ramp up and see where it goes. And then we have these Friday meetings to sort of hash out some more technical details of it. So if we want to, if you want to just kind of like propose an idea, even it can be something like that doesn't actually happen, but it's just an opportunity to do it.
Yeah, I like the idea of an open hour or like a hack hour or whatever. I may not always be able to do it. It's easier because I'm working remotely right now and I can. But
yeah.
I'll stop by as much as I can. And I have ideas too. Like I know I mentioned paper presentations, but I'm interested in like a lot of the DevoWorm ML stuff that we sort of talked about before, and hopefully I want to ultimately have some kind of a project I'm working on here as well in some form or another, even if it's just contributing to main OpenWorm stuff or getting more towards the DevoWorm ML things.
Yeah. Yeah, I mean that's pretty open. I think it was you emailed me last week about or you contacted me last week about the complexity measures.
Oh yeah.
Yeah. So I don't know. Well, I sent you that email and I just kind of gave you a folder of stuff. So I don't know if that's not really that informative, but I can tell you a little bit about that. Might as well. So this is something that we came up, Dick and I came up with a while back. We were thinking about different measures for like looking at complexity in biology, but like maybe tying it more into like machine learning pipeline. We're finding these features and we're extracting them and getting some data on them, and then after that, what do we do with it? So is there a way to like characterize it with measures that are complex systems type thing? So we potentially this could be really powerful because we could have like a bunch of data over time, and then you have all this dynamic data that I don't know what we do with it. So maybe one of the things is like work on some like nailing down some complexity measures or making complexity measures accessible to the community or something of that nature. And I'm not really sure, what direction we want to go with it. I mean, that's up to whoever participates. Like I told Krishna, if you have an idea and you run with it, that's where we go. Because that's the path of least resistance for this. So I think, there are a couple ways you can approach this sort of thing. We can either, think about, the type of data that we're going to get out of the machine learning analyses and kind of develop some measures or find some measures in the literature and put them, make them accessible to the community. So that might be like, writing a piece of code that runs the analysis, take all these things and put them in a, generate a graph that says, shows the data and shows the analysis. So that's something that could be done like in a Jupyter notebook very easily. It's a data science type thing. And then there's another way of doing this, which is to say there are these measures out there that are like maybe inaccessible to a lot of people. It could be biologists or whatever. It could be students who don't have like a lot of advanced math, because there are a lot of methods in the literature that are like just written in math, like 2 or 3 pages of math, and then they're like, okay, well, like machine learning has a lot of that. The techniques, they're somewhat inscrutable, at least. And the same happens with complexity measurements or complexity theory. A lot of it might be inscrutable to people. So how do we make this more accessible? And I found actually the other night I found a couple of examples of things that I had done in the past with some measures where it's like you draw up this diagram that shows the different steps involved in the measure. So it's like you do this step and then that step, and then you get to the end, and then that's what it is, and it makes it, I think, a lot easier to follow. Maybe for people, running code even, you look at the different steps and you say, okay, execute this piece of code, and this is why it works. Or just like, someone trying to produce code to run the analysis. What are the steps I need to do to make this happen? So there's that part of it. And there's also maybe like a complex systems element that is like creating like, some sort of systems diagram or systems analysis of some of these data, maybe like some biological process or some other thing I mean, I'm just thinking very broadly here, but those are types of things that we would look for in something like that. So I mean, it said complexity measures, but I kind of wanted to give you my thoughts about it. So I was
No,
yeah.
I'm happy to hear them. And even, like, a portion of what you said really related to. I don't know if you saw the. I've never matched the data panel.
Yeah.
Yeah, I really. A lot of the seems. Obviously, we have our own efforts in like orthogonal lab and everything else in OpenWorm just for open. But a lot of it struck me as similar to that in terms of how I really like the idea of emphasizing more organizing the data and the code in a way that's accessible and very transparent. I think that'll be important on a lot of things. And I know that's a part of a component of what you said here, but I'd be curious to look more into the complexity measures themselves and then actually it would be fun to explore the data structuring and conveying that as well.
Yeah, we've been exploring the data sharing aspect of it for a while, at least in DevoWorm. That's sort of the idea behind DevoZoo, although it's not really perfected.
Yeah.
But you have these like I think they were talking about at that session. They talked a lot about how you take a lot of times open data just means like someone takes data and puts it out there as like raw data, where they put out like some tables. They're either like really like hard to interpret and don't have a lot of metadata associated, or they're like so highly processed that like they just want you to replicate the figure, and that's somewhat useful, but it's not useful. It's like you can imagine if I basically cheated to make a figure, right? I made up data. I could just show you the data that went into making that table, and it would be hard to know like how you got to that point. I mean, I could remake the table, but what's the point? I mean, there's that seems to be like a lot of times the two extremes that you find, and maybe because it's the easiest to do. But there is this aspect of like this sort of like creating like annotation of variables and maybe creating new variables and having the whole some data that's not raw data but it's not highly processed, something that you can put up in a repository so people can download it. In DevoWorm, we have things hosted on GitHub. We have CSV files. So, like, if you comma delimit your data, you can create tables in GitHub. Like, they're CSV. They're rendered in. I think there's some sort of maybe markdown underneath GitHub, but it creates tables. So you can export those, and the CSV is a very good standard. They're also, like, I know in OpenWorm they've been using JSON for a lot of things. So JSON, of course, is some JavaScript format where you can, it's a standardized data format where you can put metadata in and table data. So it's standard if you move from one user to another. And then I think we've also used XML files as well. And, so there's a lot of, like, we've been exploring standards. We don't have a really good pipeline nailed down, but that's something that we have, and we haven't really. We may be able to tie it into like complexity measures in the sense that we can, like, develop some way to like say, okay, here's the level of data maybe we need to explore this thing, and then it relates to this measure. Like, how do we get like from like some raw data from an image data set to like some measure that we can apply a complexity measure to, but is also like sort of at the stage where people can explore it and apply their own measures to. Like, so, instead of just generating a table, you might generate like a whole set of analyses depending on what you want to know.
Yeah, that's interesting.
So I think we're heading towards the top of the hour. I don't know if there are any more questions or anything.
No.
Okay. Jesse?
No, I maybe I'll have more to say next time, but I kind of just wanted to stop by and get a sense of things here. It's cool.
Well, thanks for stopping by. Yeah. So, like I said, it's a pretty free-form meeting, but we'll have this time every week, unless I tell people that we're not meeting. Sometimes we won't meet, but All right. Thanks for attending. See you guys maybe Monday at Monday's meeting, or Jesse maybe tomorrow.
Yeah.
Okay.
I'll see you tomorrow morning. Yeah. Take care, everybody.
All right. Take care. Bye.